Hello everyone, Richard Walding here from Brisbane, Australia. I'm going to do a talk on indicator loops and how they are used for anti-submarine defences in World War I, World War II. Now let's have a look at these slides. That's the title slide I'm using. It's just basically an overview of these things called indicator loops. Now, I did this talk for the Fortress Study Group, you can see on the screen. Now they're a UK-based group, but they have members all over the world, and I did a webinar just to describe basically an introduction to indicator loops. Okay, look, the first question of course is, what are indicator loops? Let's have a look. Now basically they're just long lengths of cable laid on the sea floor, and you can see the diagram there. Big lengths. Now they could be about 4,000 meters long and probably about 400 meters wide. Okay, so each one is made up of 3 legs, they call it. Okay, so let's have a look at, I'll just show you the basic principles of this. Now I'll just get out of this screen and just show you what's going on. Now, if you imagine a loop is basically just a loop of cable. Now I've got one here. This is just, admittedly this is, if you can see it, 1200 turns of wire. Now those loops I was showing you on the screen are only one loop, if you like. Okay, so basically they're just on the sea floor, and if you think, we've got a meter, a sensitive meter. In this case I'm using a microammeter, and if you think a submarine, I'll show you why later, but a submarine is basically a magnet. There's my north and south pole of a magnet. Watch what happens as the magnet goes across there. Now you can see as the ship goes across this loop, you'll be getting a deflection. Okay, so it goes one way, 0, and then the other way. I'll do that again. One way, 0, and the other way. That wasn't very good. One way, 0, and the other way. Okay, so that's the basic principle. Now that was discovered by Faraday back in 1831 or so. Okay. Now I'll just show you some of this cable. Here's a picture, and this is actually the cable that was recovered from Haifa in Israel in World War II. I'll just show you a close-up of it. So that's the piece that I've got on the screen. I'll get it orientated the same way. Okay, and I'll just run through some of the characteristics of it, some of the parts of that cable. Okay, so let's go back. Whoops, wrong one. Now, and I'll describe the rest of the cable later in detail. Look, what I've got on the screen are some of the harbours that were defended around the world with loops in World War II. Okay, now we can start right up here. This is in Alaska. You can see up there, this is Woody Island near Kodiak in Alaska. Coming down Prince Rupert over here, and then on the the eastern coast of the USA, you're going from Canada. That's St. John, the first one up there, and then you've got all of these. There's a whole bunch of them. There's about a dozen different loop defended harbours on the eastern seaboard of the United States, from New York down to Boston to North Carolina. There's a whole lot, and I'm not going to go through those in any detail other than to say there was a lot of harbours there defended by the United States Navy in World War II. Then coming over here, there's the UK. I mentioned Oban before, so in Scotland there's Oban. There's May Island over here in over near the other side, near Firth of Forth, near Edinburgh. Down below this we've got places like Malta, and what else have we got there? No, that's not Malta. That's Isle of Wight, the south of England, and over here we've got Breskens in Belgium. Down here we've got a whole lot of places: Algiers, Malta, and Crete, Alexandria, Haifa I mentioned in Israel. Down here we've got in Kenya, and in what was the other one over there? That's in Tanzania, of course. And then we've got Durban and Cape Town and Port Elizabeth. Okay, that's in South Africa. Way over here, we've got a number. There's Hong Kong, Penang, Singapore, and then in Australia we've got Darwin, Perth, Brisbane, Newcastle, Sydney, and then in New Zealand we've got Auckland, Wellington and Christchurch. Okay, so the next slide I'll just put all the names in so you can see them. If you're ever looking back through this slide or this video, you can just stop it there and have a look at all the names that I just mentioned. Okay, so they're the ones defended by loops in World War II. Okay, let's have a look at one in particular. Now I mentioned Oban in Scotland. I've just shown you where Edinburgh and Glasgow are in comparison, and the Oban loop was across here, okay, defending this area, which was where the convoys set up for going over to United States in World War II. Okay, we can zoom in on that. I'll just show you. Now I've just done a Google Earth zoom in here, and I'll take you straight into Oban. Okay, we're zooming right in. Okay, so that's a close-up of what I was showing you in Oban. You can see the Oban, there's the loop hut there in the middle. This is Glenarvan Beach over here, and Oban is just a little bit further to the south, a few kilometres to the south. But that's the loop hut, where the indicator loop meters were, and over here is the generator hut. Okay, so I'll just take you out of that, and whoops, and we are on the headland now. So I was showing you in the video. That's the loop hut, and there's the generator hut. Okay, in the background, I've named these, so we'll have a look. Isle of Mull in the background. So the loop, as I was saying, goes across from here at Glenarvan Beach in Oban across to the Isle of Mull, because the convoys were set up over in here. That's their meeting place. Okay, the loop hut, the generator hut I've just mentioned. Okay, now looking from the other way, this is looking from Isle of Mull back towards Glenarvan Beach, or back towards Oban. There's the loop hut. Now you can just see the generator hut down there. It's a little bit lower. Okay, and the loops would have come out across here. Now I'll put that in the next picture. Okay, you can see there's the tail cables. Now they'd be underwater. They might be under 10 metres of water there, but that's the rough position. Now those hills in the background, or mountains in the background, are about 34 kilometres away, 35 kilometres away, and they just look close up because of the lens, because of the telephoto lens. Now these photos were taken by Martin Briscoe in Fort William, and he's been my collaborator on the work we've done on Oban and the loops there. Okay, now here's a close-up of the loop hut. You can see it's made of brick. Now there's a little measuring stick there. Here in 10 centimetre segments, but you can see it's made out of brick, and it's been rendered in concrete, obviously to disguise it, to camouflage it a little bit. Now you can see a couple of rooms here. There's one room here on the left. There is a dividing wall through the middle of it, and then there's a second room here. Okay, so now I think I've named these. So that first room you could call the binocular room. That's where the officer would stand with the binoculars looking out over the Isle of Mull, and you can see it down there in the background. Over this side, this room on the other side, is the watchkeeper's room. That's where they would have had the meters for the indicator loops. Okay, and the generator hut, which was down lower, there's 3 rooms in that. The first room is just the fuel store. That'll be full of diesel fuel, and in the generator room they would have had a couple of diesel generators. They generated DC, maybe 32 volts or something like that, and the artificer workshop, or the Tiffy as they would have called him, is here. Now they would have had batteries on charge, plus all the tools for running the generators and the motors, and also running the equipment in the loop hut, because they were sensitive galvanometers, and they needed not so much sort of, they didn't have to do a lot with them. They were pretty stable, but paper had to be changed in the meters and in the paper recorders and so on. Okay, now I'd like to go to Australia and just have a look at the one in Australia, because I'm familiar with this. Now I live here, as I said at the beginning, I live in Brisbane, but I go up to Bribie Island a lot. That's where the loops were, in this island called Bribie Island, or in the harbour, in the bay near Bribie Island. Some of the other places I mentioned, Darwin, there's loops up there. Perth, there were loops, or down at Fremantle, which is on the waterfront. Sydney, I did mention Newcastle, just a bit north of that. And there were loops up in Port Moresby. Okay, so I'll take you from here, which is the loop hut at Oban. Let's zoom across to Australia, and I'll get Google to do that. There we go, past India. All the way to the loop hut at Bribie Island. So there's the Bribie Island beach. There's the loop hut, about 10 metres by 10 metres and a couple of metres high. I'll just go and have a look at that one again. Oops, here we go. That's on the beach. Now I'll show you the various rooms. This is where the watchkeep or the binocular room was. So there'd be an officer in there with binoculars or a little telescope. This is just the wireless telegraphy room where you'd have a watchkeeper, usually a able-bodied seaman, so an AB would be in there, but not in all loops around the world. Not always did you have seamen in the as the watchkeepers. You could have a mixture of land-based people in the Navy, or you could have seamen. Okay, and there's toilets at the back there, the officers' toilets around the other side of the sailors' toilet, or the ratings toilets. Over this side, now that's not the meter room or the watchkeeper's room. That's for a thing called the HDA, the Harbour Defence ASDIC. Now that was like a sonar that was underwater near the loops. I'm not going to go into that. That's a whole separate sort of defence system. But behind that is another room where you'd have the loop recorders. In the case of Bribie, there were three loop recorders, and so you probably would have had two watchkeepers on at any one time, just looking at the paper charts or looking at deflections on the galvanometer, mainly the paper charts. Okay, and then behind that was the Tiffy's room, where they had a lot of batteries. Batteries were there to run the equipment off the DC. In case there's a power failure, that DC would take over. Well, the DC was always, the batteries would always be there to provide the power. Now you'll notice over the side here, there's a lot of cables on the beach. Now they're just loop and tail cables. The entrance into the hut was this little cutout here, so they came down the beach like that from the water. But these were just broken off. Now remember, this photo was taken, well, it was probably 5 years ago, so in the 2000s, and 2010 maybe, yeah, so 10 years ago, 12 years ago. But these cables were here, are from World War II, so 1943 basically. Now I cut some samples of that to dissect, so I can have a look at what was in them. There's no need to think that I'm destroying military artefacts, because these cables were being pulled up by the council with a tractor, pulled out of the ground and taken to the dump, just as scrap. So I managed to rescue some of those. Now the walls of this building were a foot thick, so 30 centimetres thick, of really high quality concrete. Now the concrete, the sand wasn't just the sand from the beach. They used proper river sand, which was free of salt, and it was really good. Now the concrete has been tested recently, and they found out that concrete is just superb. It's got really high strength, and it's lasted over the years. What's happening though is the steel, this is steel reinforcing, you have the concrete cancer, if you like, and the concrete's breaking away because the steel's rusting inside. Okay, here's a picture of or a drawing I did of what the loop looks like, what the loop hut looks like. Now, from the front, I was telling you the loops came up from the beach there, and I just said beach. So there's the observation room, which was the binocular room where an officer would have been stationed with binoculars and telescope. This is the Harbour Defence ASDIC room, so the HDA room. We're not really talking about that today. Indicator loop room where the watchkeepers, the ratings would have sat. There were just stools here in front of these instruments, and they would have had two watchkeepers on, two ratings on at a time, watching those loop instruments on the wall. The artificer's workshop is here. They had batteries all lined along this wall here. I've been inside this hut many times. The ratings toilet, officers' toilet. The only difference is the officers had Royal Dalton. The ratings had a cheaper type of porcelain. Wireless telegraphy room where they'd be able to radio through to the control centre, which was probably about probably about 20 kilometres away, at a place called Caloundra. Okay, let's move on. Look, just having a look inside the observation room. Now, the volunteers have put some shade cloth around there to stop people throwing rubbish in through the window, and they actually put some well mesh steel on it to stop stuff being thrown in as well, and people crawling in. For a long while, people would crawl in through the windows and open the doors and do camping in there. But so concrete walls, concrete floor, and you can see this is where the cables came up through the floor. There's some little battens there. You can see here, this is in the HDA room. The cables come up from the beach through that, and then they go off to the various instruments, or over, or basically to the various instruments from this set of trenches here. And here's the inside a trench. You can see all the cables, and there's someone holding one of the cables. You can see the relative size of it, like I tried to show you earlier. Okay, outside, here's the cables on the beach, rusting away on the beach, and I grabbed some chunks of that with a hacksaw. These aren't all tail cables or loop cables. Some of the bigger ones are the tail cables, but you've also got cables from the generator huts and so on. Okay, we'll move on. Now, in side of one of the cables, I cut it open. You can see it says Edison Swan Cables, Lidbrook, Gloucestershire, 1940. Okay, so it's a little tape just to tell you who made it, and you can see the various wires inside there. Now, you can't see the armour wire on the outside. That's just the rubber insulation inside the wire, but at least I've just shown you that this is genuine loop cable. It's not just some more recent cable that's just rusted away. Okay, let's have a look at how the whole thing worked. Now, this is on Moreton Bay. Now, you can see here the place I was just showing you was a place called Wurrum. Now, this is Bribie Island, so that's about halfway down the eastern coast of Australia, and we've got another island out here, Moreton Island, and there's the capital city of Queensland, which is Brisbane. Now, there's a whole lot of docks and so on in there, so this is a major port. Now, in World War II, things didn't really heat up until after Pearl Harbour, and after the Japanese attacked the fleet, the US Navy fleet at Pearl Harbour. And pretty soon after that, Bribie, we already had the loop station set up, but what really happened in sort of in the early part of 1942, they really got moving with this. So what happens is the ships would come down, they'd approach Caloundra from the Pacific Ocean, they'd come in here, approach Caloundra, get their clearance, that was where the port war signal station was, so they would indicate, you know, with their Aldous lamps and so on, that they were coming in. They'd come down here. Now, in a later video, I'm going to talk about Fort Bribie, which was just where I've got the arrow. There are the guns there. There are two 6-inch guns, and so the ships would come down the Northwest Channel. They'd come across here through this channel down here into Brisbane. Now, the best place for indicator loops turned out to be across this main channel here, so that's where they put them. I'll show you that in a minute. Brisbane became, why Brisbane's so important was that when the United States Navy was engaged in the Coral Sea, which is to the south, to the north here of Australia, just to the northeast, if you like, they were using Brisbane as the submarine base for the whole operation. So that was from early 1942 till the late 42, for I think it was about 9 months or so. Brisbane was and in fact Brisbane was the biggest United States Navy submarine base in the world. It was bigger than anything in mainland the USA or even Hawaii. So we had, when we say we, I said basically there were about at any one time there were only maybe a dozen at the most subs in port there, but over the 9 months there were about 30 different submarines visited. They did something like 90 operations out of Brisbane, so it was very active. Okay, so this is how the loops were laid out. As I showed you in the first slide, they were called three-legged loops, and so there were 4 of them. The first 3 were controlled from that little hut I showed you on Bribie Island at Wurrum. That was called RAN4. That was Royal Australian Navy Station number 4, Naval Station 4. Over here on Moreton Island, at a place called Comburo Point, there was one loop hut. Well, there's a loop hut with one loop machine in it, one loop galvanometer machine, and that was called Royal Australian Navy Naval Station number 7. Okay, and these, I've shown you the tail cables. Okay, now that's about 16 kilometres from one side to the other, and there's 4 loops, so they're about 4 kilometres, 4,000 metres each. Some were smaller and some were bigger, but on average they're about 4,000, or probably a little bit under on average around the world, probably 3,500. But around about close to 4,000 yards in the imperial measurement. Okay. That's over in Comburo Point. Now they only had one loop machine over there, but that's the loop control hut on the other side. Now this is just an image of what it looks like inside a loop hut. Now this wasn't the one at Bribie. We don't have, I mean, photographs weren't allowed during the war, even though some soldiers had cameras. They never dared take photos inside the huts. They just took personal photos of, you know, just horsing around on the beach and so on. But the main thing here is over on this pillar, there's a big concrete pillar here. There's 2 galvanometers, excuse me, is sitting there inside this case, and then the signal from that comes to, you've got some amplifiers, and these are the paper recorders. And this is for 2 loops, obviously. Now this is taken from a training room in Sydney, so it wasn't actually an active loop station. It was just the training room in Sydney, at Rushcutter Bay in Sydney, where all the sailors were trained. Now you had these, basically they were just variable resistors. They were used to control the resistance of the 2 loops, or in this case the 2 loops. So let's imagine this is loop 1, there's 3 legs. What you could do is control the resistance of each leg, so that you were getting, or you just control the sort of the size of the signal, and you wanted to be able to balance them, so you can do balancing between the various loops as well. Okay, I think this is a motor drive to run the paper recorders and so on. Okay, This is a picture of the galvanometer. It's actually, they called it an integrator. It works a bit different to a galvanometer. It measures the total amount of magnetism passed through the loops, not the rate at which it changes, like an ammeter, like I showed you before. An ammeter is only picking up the rate of change of magnetism or magnetic flux. These are measuring the total magnetic flux. Just a bit different. In some ways it's like having a galvanometer with a spring taken out. That's how I'm a physics teacher, I tell my students that. Okay, you can see a little mirror in the middle, so light shines on the mirror and comes out onto a scale. Now that's a one I bought. I've got this at home, and it's actually behind me somewhere, I think in the video. I'll just see if it's there. Yeah, there it is. You can see it sitting there on the bookshelves. Okay. Anyway, I bought that. That was $250 US. It actually came from New York, but it was used at it's St. John in Canada during World War II, and it was sold. I paid $250 US, but by the time it got here, with shipping costs and customs duty, it ended up costing about $750 Australian. But at least I've got one. There's hardly any of those left in the world. They're all destroyed and used for scrap. Now, I said the ratings just took photos of, not of the equipment, but of each other. There they are. Now, those ratings would have been in their early 20s, probably 22 to 30. Sometimes they were from ships that had been sunk, and they were the survivors, and they just needed to give them a few months on land to recover from the ordeal. There's nothing physically wrong with them, but they just needed a bit shaken up. Others were just regular ratings, had no mishaps, and they were just sent there. Okay, here they are horsing around Christmas drinks. I think they had beer in this sack, and they're putting it down the well to get it cold, pretending to drink. Okay, now what I'd like to do is go from here, which is the loop hut that I just showed you on the beach. I should have mentioned just over here, a little bit past this car park, is a generator hut, and there's another generator hut down here, about 200 metres away from the loop hut itself. And the accommodation for the men was back in the bush here. Okay, I'll take you from there over to Edinburgh Uni. Okay, here we go, past India, past Europe, into Britain. Okay, we're up into Edinburgh. Now this is called Drummond Street, so this street here is Drummond Street, Edinburgh. This is the old physics laboratory. It's no longer there. That building's still there, but it's no longer used for physics. I think the geographers have taken it over. Okay, just the 2 streets back to the top here is the Royal Mile. That's where the Queen, the Queen's body was processed after her death in 2022, and so it's not far away. Okay, so what I want to have a look at now, this is a recent photo. This is from Google Earth, just in 2022, but you'll notice there's a pad here, and it looks pretty flat. The physicist, oh by the way, this is the physics room here. You can see some skylights here. I'll show you those in a photo, but that's a part of the physics lab in there, and there were lecture theatres and so on, physics. So this end really was the physics end, and I'll show you inside. But why I've got this here is the scientist who developed the loops, the indicator loops, was doing an experiment in about 1881, and he wanted some water to freeze, and he came through this door and put a bucket of water there. He needed ice for an experiment he was doing. Okay, and I'll just talk about that experiment because it was vital in the history of indicator loop. Okay, here we are inside. So this is 1886 inside the physics theatre. This particular instrument here is what the scientist, now the scientist's name was Professor Crichton Mitchell, and Alexander Crichton Mitchell. He was doing work on the specific heat of ice. No, the thermal conductivity of ice. And so he had this tub basically up on the roof to try and freeze it. He had a couple of thermocouples in there, I'll show you later. And you see a lot of all the other equipment that was there during the time. This is inside his lab. There's the skylight I was talking about. So he would have had stuff set up in here doing that experiment. Okay, that's him there, Alexander Crichton Mitchell. That was taken in 1890. He did his studies there, his degree from, I think it was about 1881 through till 1885 or something like that. And then he headed off to India, and I'll show you that in a minute. That's where a lot of this development took place. Here's the instrument he was using. Basically, he had this block of ice with a couple of thermocouples in there, and he was measuring basically you can measure the temperature by measuring electric current basically from a thermocouple. Now what you'll notice here, the wire's going around, and he had a loop of wire here. There's a galvanometer. He had a loop of wire here, so that's like a loop that I was talking about. Now what happened was, this is out of his journal article from the Royal Society of Edinburgh. I suppose I should read it. Shortly after 6 p.m, the galvanometer was seen to give irregular deflections even when not included in one of the thermoelectric circuits. These deflections continued to increase to such an extent that the directing magnet had to be shifted to keep the light spot on the scale. These phenomena were found to be due to the disturbed state of the Earth's magnetism at the time, for from 7:30 p.m. till 8:30 p.m. on that evening, a brilliant auroral display took place. Now, the aurora is basically to do with the magnetic fields, changes in the magnetic fields of the Earth. So the changing magnetic field actually threaded through the loop that I was showing. So this loop here, because he was in Edinburgh and the aurora was seen in Edinburgh, the effect of the changing magnetism would have been picked up by the galvanometer. Now, he wasn't overly pleased with that. It annoyed him because he had to go and do the experiment again. There's nothing he could do about it. He couldn't stop it. He just had to put up with it and then do it later. Okay, so what happened was after he had done his work, he got a job as a physics and maths professor in India. Now I'm going to show you where he was. It's down here in this little state down here called Kerala. Okay, at the time it was called Travancore, but that included a lot bigger area. Okay, included parts of these other, what they call princely states. So he was down here in a town called Trivandrum. I'll just show you that. Okay, now I've been there. I went there to follow in his footsteps to see the lab he worked in and all the equipment he used. But that's where he spent the next 24 years of his life. So up until about 1912, he was stationed there, and he went back to Scotland probably every few years. He was on quite a good wage, and they paid for an annual, or not an annual, but they paid for travel costs back to England. Okay, so I think he used to go over to Madras and then get the ship back to, basically up past the Red Sea, back to and get a camel train across Egypt, and then across to France, and then to England. In some part of it he could have gone around the Cape. We're not quite sure, the different routes he took, because he was there for such a long time, and the travel changed. Okay, so let's go from here to the Maharaja's College where he worked. Okay, let's see if this works. So I'll take you from there. We'll zoom across with Google Earth back to India. Here we go. And down into the southern state of India. We'll zoom right in. Now there's the Maharaja's College. I stayed just in a hotel nearby, and I spent a lot of time at the college. Basically, this is the physics lab at the back of the college. Now there's the main road here, and you can see there's the administration building, the original building. This was built a little bit later. but his lab was on this side. Okay, so that side was the physics lab and the physics lecture theatre, and the other parts were maths. You had chemistry, but I don't think the chemistry was in that building. That was really the physics building, plus they would have taught maths. And because physics was a part of what they call natural philosophy, which included mathematical physics, they called it. Okay, so let's have a look inside. Oh, I went there. Look, I made front page of the Hindu, and just talking about the submarines and, you know, the relationship between the submarine history, or the history of detection, and Mitchell's work in India. Okay, there's a photo inside the lab. Now that's Mitchell's lab, where he was in the 1890s through till 1912. So a lot of that equipment is from there. You can, if you look at some of this, I think that's the barometer, and it's actually got the date of manufacture, which was back in the late 1800s. You know, Thomas Grubb, Dublin, for instance, and you know, just equipment that's been made. It's been updated a lot since then, but they've kept a lot of the equipment. Okay. Now that's the Royal Observatory. It looks a bit run down, and it is a little bit run down. You can see the observatory, basically the watchkeeper is there, and one of my colleagues, Dr. Archu Nair, is just standing there. He got me access. You're not supposed to go in there without permission, but he managed to get permission, and we could walk around it. You can see the words OBS, Observatory. That's the library and study rooms there, and you've got telescope rooms up top and down in here as well, and there's another library with all the records kept in there. Okay, now let me go through the theory behind all of this. Now what I've got here is just a picture of the a diagram of the Earth, and you know there is a geographic North Pole, but there's also a magnetic North Pole which is nearby, and it drifts a little bit, but basically that's the geographic North. Now that's the centre of the axis on which the Earth rotates, and there's a geographic South Pole. But there's also a North Pole, magnetic North, and a magnetic South. Now look, I've drawn some compasses in here, and the red end of a compass is the end that points north. Okay, and it's called the north-seeking pole. Well, today we call it the North Pole. So the red pole is north. Now, you know from your own studies in physics that unlike poles attract. So if that's a north pole of a magnet, it has to be attracted to a south pole of the Earth. Now I've shown that as a blue magnet here, blue end of a magnet. So that's basically, now I know this is not what happens, but you can think of the Earth as being, the Earth's centre as having this huge magnet inside it with a south pole, I'll just show you that, and a north pole down the bottom. Okay, so the north pole of a compass, the red end, is attracted to the south pole, unlike poles attract. So in the ground, if you like, there's this huge magnetic pole. Now it's not a permanent magnet like that, it's circulating ionic or circulating charged particles in the Earth that cause this magnetic effect, or the Earth to have terrestrial or Earth-based magnetism. Okay, so if you keep in mind that the north end is red, because in Navy parlance they often talk about the red magnetism, and they really mean north. Okay, now let's have a look. If you were building a ship, and let's imagine this is a ship being built in maybe Edinburgh, not Edinburgh, but somewhere in the northern hemisphere, in England somewhere, or Scotland, up around probably a latitude of say 50 degrees. So there's the 0 latitude, that's the equator, and let's say that's 50 or something like that. Now you notice the magnetic field from the Earth goes down from the top of the ship down into the bottom of the ship, so it's in that direction. So the bottom of the ship would be called red, because that'll be the North Pole, because it's attracted, or it's basically close to the South Pole. There was an attraction there. So in this diagram, the next diagram I'll show you, can you imagine they're the field lines, the Earth's magnetic field lines going through a ship. In this case I've just got a submarine, and the field lines are in that direction, pointing towards the magnetic north of the Earth. But I've just got this on the horizontal now. Okay, what we do in physics is to indicate the direction of these field lines, we put a little circle and with a cross in it, and a circle with a dot in it for the tip of the arrow. So you can imagine if your eye was down here and looking at that arrow, you'd see a little point, and that's shown by the arrow. If your eye was up the top here, you're looking at the end of the arrow, you'd see the tail feathers. So we indicate with a cross and a tip, cross and a dot to the direction of the magnetic field. Now, like I said before, the hull of this ship would be a north pole, so it would be called a red, so, or north down. So in Navy parlance they'd say this ship, its magnetisation is north down, or they'd say it has red magnetisation in the hull, and they're the sort of words they use. And it gets confusing when you read through the archives trying to work out what they mean. Okay, let's imagine a Japanese submarine. Okay, so it's the same thing. Japan being in the northern hemisphere, the submarines built there would be north down. So boats that spent most of their time in the northern hemisphere were north down, because they were in the Earth's magnetic field, which was pointing north down. Okay, but you could get a case if they came down into Australian waters, if they were here long enough, the Earth's magnetic field is pointing upwards, so you'd get north up or south down. So you'd talk about the hull being blue magnetisation. Okay, now that's only if they were here for a long time. It took a while for the magnetism that was sort of built into the boats when they were originally built, and all the banging of the the rivets and putting the motors in, and the vibrations in the Earth's magnetic field would have caused originally to be north down. Ships built in Australia would have been naturally south down. But when the Japanese submarines came to the southern waters, if they're here long enough, they could be south down. Okay, let me just talk about electromagnetic induction. So when a magnet moves past a wire, like I showed you before, electric current is produced. Now that was discovered by Faraday in London, the Royal Institution, 1831, and there are rules for working out the direction of current. Now I've said electric current is produced, I've got an arrow going that way. In physics we talk about the positive electric current, or the conventional current, which is the motion of a positive charge, and it moves and accumulates at this end, so that end becomes positive. The other end is the absence of the positive charge, so it's negative. Okay, so there's a voltage produced across that, or if you like, a current is produced, and that was, as I showed you on the meter I had before. Okay, so here's a submarine going across some wires. Now the submarine, as I said before, is either north down or south down, unless it's been wiped. Now you can deperm a submarine, so you can get rid of the permanent magnetism by putting it in a reversed magnetic field, or basically they use alternating current to gradually reduce it down to zero. And they even have basically cables on the ship which will maintain, which they can work out to how much current is needed and in what direction to give the submarine or ship an overall zero magnetisation. So here's a ship. Let's imagine it's north down, going across a loop of 3 legs, and you can work out the direction. If it's heading in towards the right, electric current is produced, and there are rules we use for working out the direction of the current. I won't go through them now, but there are sort of hand rules for it. Let's go and have a look at Leith in 1915. Now this is in Leith Harbour, which is just basically a suburb, if you like, of Edinburgh, but back then it was back in 1915 it was considered a separate town. Now, in March of 1915, the war had started with Germany, and there were German submarines were up and down the east coast of Britain, as well as a lot of other places, but they were going past Edinburgh. And this particular ship, the Fingal, was sunk in March 1915 off the Firth of Forth, so off Edinburgh. 6 people killed. Now that's it at the West Pier. This is the West Pier of Leith. That's the East Pier over here. Now the reason I mention this is because when Mitchell came back from Edinburgh, came back from Trivandrum in India, he did some experiments here, and I'll show you these. But this got the loss of ships off Edinburgh in particular got a lot of people really worried, and there was one family that donated money to the Royal Society of Edinburgh. There's a few £100 for detecting and sinking submarines, and a whole lot of other things to do with gas warfare and so on. 2 of their sons were soon to be lost in the war, and they were really worried, and they were killed. One basically by the Germans and the Turks. So these people were prepared to donate money to the Royal Society of Edinburgh. Now, here we are. This is in May 1915. So a little bit after that photo I just showed you. This is the West Pier, and you can see ships lined up here. And Mitchell, Alexander Crichton Mitchell, came and stood roughly where this guy is standing here, and had loops of cable in the water, similar to the one that he used in the tower above the physics lab in Drummond Street, Edinburgh. So he took bell wire, which is just a stiff copper wire, very thin, but maybe I wouldn't be even maybe a 0.5 millimetre diameter wire, covered in rubber or gutta percha or some sort of insulation. He threw it in the water, and I'll go through that in a minute. But he came and did his experiments in about August. So I'll just take you into the pier today, and you can see what's happening. Okay, so you recognise the UK, and we'll zoom in to Edinburgh. This is Edinburgh. Now we're into Leith, and you can see that's the West Pier. It would have gone from back here. It's all been built in now. That's the HMS Britannia, the Royal Yacht. So that's the West Pier. That's the old remnants of the West Pier there. So let's have a good look at this. Okay, there's a close-up of the West Pier. Now, that's where those people were standing in that previous photo. So Mitchell came and stood on this West Pier and did his experiments. What he did was he threw a loop of bell wire out into the channel like that, August 1915, and as ships went over the top of it, you got a signal like I was showing you on a galvanometer. Okay, now this is what he said. Came down at the beginning of the month. I got good results with a vertical coil. Now he tried it vertically first, and he got some good results. And then he tried submerged in a horizontal plane like I just had in the diagram. He says it was too delicate. So much so that we picked up minute variations in the Earth's field, and these masked the disturbance due to the submarine. I've marked out a method for neutralising these, or rather neutralising their indications, on the galvanometer. I hope this starts next week. Now look, let me just show you how this works. Now there's a loop. Let's imagine that's lying flat on the floor of a seabed, even in the channel at Leith, and there's a sub going across the top of it. Now it could be a ship, but in this case we're interested in subs. So that's a north down sub, and as I said before, they're like the tail feathers of the arrow. So the arrow, the magnetisation of the sub is what we say in physics is into the page, in your case into the screen. Okay, so as it goes across, you'll get a deflection. Now I showed you the deflection on the microammeter before, but it goes in one direction as it crosses one leg of the loop, comes down to 0 as it goes in the middle of the loop, and then in the reverse direction as it goes across the other leg of the loop. Now that'll be the inner leg, if you like, close to the closer to the port. Now that's what it looks like in theory. I used Excel and my formulas for strength of a magnetic field and distance and so on, and that's what Excel said it should look like. So what I did was I tried that with an oscilloscope. I've just got a digital oscilloscope and a coil and a magnet like I had before, and that's the image I got. Look, that's almost a perfect match for the theoretical. Okay, so that's for a single loop. Now what Mitchell did was this is pretty clever. He did a figure of 8 loop. Now I'll just show you. Look, I'll go back to this and show you. That's basically a loop of wire. Okay, so end on it looks like that. Okay, and so the submarine, if you like, look, here's a north down submarine. All it is I've just got a piece of wood here with north and south written on it. So that'd go across the loop, and you'd get a deflection on as it went across the loop. Now the trouble is, the Earth's magnetic field would be coming in and out of this as well. Okay, so that varies during the day. Now that could be also due to what we call industrials. So if there happens to be some trams or trains nearby, or electric motors, you can get these industrials as well as the terrestrials, which are just the variation in the Earth's magnetic field. So they'll give a signal themselves. So that will affect. So when a sub goes across, or a ship goes across the loop, not only have you got the signal from the ship, but you've got all these other terrestrials and industrials affecting it. Now what Mitchell did was he took his loop like that and he turned it into a figure of 8. So it looks like this now. Okay, so if I put that side on, what happens is, I'll do it like this and you can see what's happening. What happens is, if a ship goes over one part of the loop like that, you'll get a signal, or if it goes over the other part of the loop, you'll get a different, you get the same sort of signal. But the Earth's magnetic field and these industrials will feed through both loops at the same time, whereas a submarine will either be in one loop or the other. Now because they're in opposition to each other, we've put them in basically the loop's been flipped over. Any industrials produced, or terrestrial magnetisation produced in this loop, where are we, this closer loop here, will be cancelled by the magnetisation in the other loop. Okay, so if I hold it like that, you can see one loop basically cancels out the other loop. But for a submarine, it doesn't cancel because the submarine goes over one or the other. Okay, so that was Mitchell's brilliant idea. So that became a figure of 8 loop, and known as a Crichton-Mitchell loop. Okay, so this is closer to reality. What they had in World War II. About 200 yards between the legs. You've got the middle leg made up of 2 cables, and the outer leg. So you've outer leg and inner leg. The outer leg was the one that faced outwards towards the ocean. The inner leg was facing towards the port. These are 2,000 yards in this case. And I said they could be up to 4,000, 3.5 to 4,000 yards. And you've got the 3 terminals here. The 2 middle ones were joined together, but you also had the outer and the inner leg also joined together. So the galvanometer sat between B and the combined voltage at A and C. Okay, so when a submarine went across the cable, you got a big deflection across this first cable here. It went to nothing. Then as it went across the middle, big deflection here, then nothing in the middle, and then a big deflection in the downward direction here, and then nothing, and then a big deflection in the upward direction. Now you can use your hand rules and see how they're connected to work that out, but this is what it looks like. Okay, so as you go across the outer leg, you get a big deflection. The middle of the first loop, nothing, and then the center or the middle legs, you get a big deflection. Now it's twice as big because you've got the current feeding in from both loops. So it's a big negative one, and then it goes positive again and then back to nothing as the ship leaves the loops. Okay, so what does that look like when you hook it up to an oscilloscope? Well, this is what I did. I just made up a 3-legged loop and took a neodymium magnet, so I wanted something fairly strong, and actually just ran it past the 2 loops. I got that lovely picture on the oscilloscope. So that seemed to work. Here's an image taken from the USA. Now this was a loop receiving station from Fort Williams on the east coast of USA at Portland. But that was not an enemy ship, that was the USS New Jersey going across it. But you can see the paper chart, beautiful shape, just like I got on the oscilloscope, or just like we get in theory. Now that looks like a W upside down. They call that the inverted William shape in Navy parlance. So you could either have a William pattern or an inverted William. Let me take you now to the Eskdalemuir Observatory in southern Scotland. I'll just go from here, and this is where Mitchell got his next job in about 1918. He went here, and that's the observatory. Now what happened was Mitchell's results were so good, but this was getting towards the end of the war by the time he got it all sorted out. The Royal Society approached the Navy to try it out. So they tried some practice loops in the Firth of Forth between a place called Inchkeith, which was an island just near Edinburgh, across to Aberdour, which was just on the mainland. So it's a few miles, and they tried some cable. Now after the war, Mitchell knew the cable was there. The war stopped in 1918, or basically in 1918, and then he asked for the cables a year or 2 later. He thought, well, they're not doing anything good there. I'm going to do some experiments with Earth's magnetic field. So here's the Eskdalemuir Observatory. You can see the observatory there. They're the grounds. Now this was just big open areas of land nearby. They'd been cleared. You can see how clear it all is. But he, in his paper he wrote about it, he said, look, here's the Eskdalemuir Observatory area, and he got this cable that he used for trials in World War I, and laid it. He got some horses to drag the cable in this huge, not circle, but huge ring, if you like. And he was measuring the Earth's magnetic field through that loop. Okay, now he wrote up his experiments, and I thought, well, he never mentioned pulling the loop up, so I spoke to one of the technical officers who worked at the Eskdalemuir Loop Magnetic Observatory, and I said to him, do you think the cable would still be there? And he said, well, there's no reason why it wouldn't. He doesn't remember it ever being pulled up. So he said, I'll go and have a look. So I gave him the map of where it should be. This is John Riddick in Christmas 2005. He went hunting for it, and with his shovel, and he detected it with the metal detector, dug a hole, and sure enough, there's the cable. Okay, we got a piece out. He sent me some down to Brisbane, and that's what it looks like. There's the shielding. Now this would have been in World War I. This would have been in the water off Edinburgh. So there's the iron or steel shielding around the outside. Now that was galvanised, and you've got various layers of jute. Now there's some lead there and some cotton material, and here's the 4 cores, and they're insulated with like a rubber. Now look at this diagram. I did a cross section. You can see the copper in the centre, and then there's layers of rubber around the outside, and then they're packed with like a hemp, and then there's the lead. There's more hemp and jute, and soaked in bitumen and so on, or tar, some sort of tar, and then there's the wires around the outside. Okay, so I cut that open, and sure enough, it mentioned the Liverpool cable. So that was from 1915. Okay, now there's this is the cable I was talking about from Haifa in in Israel. So that was recovered a few years ago. Now that cable was used in the detection of a submarine that was sunk in Haifa, in the harbour there. And when we cut that open, it had a piece of tape inside it which said Henley's Telegraph Works. Now that was, and it mentioned the year, I think it was 42. And there's a cross-sectional view, and you'll notice the 7 conductors in the middle, just copper wire, and the rubber and the jute and the hemp and the lead. Now that's the lead, called the lead loading. It's lead wire. Now that's 100% lead, not 99.5 or anything, but 100%, or plus or minus, I suppose, 0.05%. But I sent that away to a lab to have it tested, and they said it's basically pure lead. So it's good quality control, and there's more jute and so on. And then there's the steel wires, and you can notice the wires are coated in zinc as the galvanizing. Okay. There's the cable. It was actually 1940, I was wrong. Siemens, London, 1940. So that's who made the cable, and it was shipped across to Haifa to be laid in their port. Here's the one I showed you. This was on the beach at Bribie. A similar company, Edison Swan, and Edison. What was the previous one? Siemens. That was the competing company, but produced the cables. Now here we are in Haifa. Now you get the orientation right. This is Israel here, and you've got the other places, Jordan and so on, and here's North Africa over here. Now the port of Haifa was an important port for shipping for the Royal Navy, for England. A lot of oil came into Haifa, for use, well, oil just as fuel oil and so on. Here's the Haifa Bay, and you can see there's the loops, 6 loops, each, like I said, look, there's the 2 nautical miles each, so scale there, and so they're about 4 miles each, roughly anyway. Okay, now so that's the Haifa Bay, protected by the loop, the anti-submarine loops. Here's the port down here at the bottom, and the loop control huts were in 2 places, some down here controlling these bottom loops, and then there's another one up here controlling the couple of loops up here. Now there was H, that's for a hydrophone, which was like a acoustic detector underwater. The wreck of the Italian submarine Shearer was destroyed by depth charges after it was detected crossing one of the loops. Okay, and we've written papers on that. The main collaborator here was Dr. Udi Galili. Now he's from the University of Haifa, but also an underwater archaeologist. He recovered a chunk of the loop cable, and he sent me some of that. And the other person we were working with was Fabio Roberti from Italy, who was most interested in the fate of the Italian midget submarine that was wrecked, the Shearer. So there's the wreck in Haifa Harbour, and you had some divers laying wreaths because the submariners that trapped in there, they died in there. Okay, so it's a war grave. Okay, in USA, here's one of the ones that are remaining. There's not many remaining, but this is at Nahant in Massachusetts, and they would have had the meters inside here. This is the loop receiving station. Now, as well as that you would have had a thing called the Harbour Control, Harbour Entrance Control, basically station, and that was more or less the control station for the loop receiving station. This is basically just where the loops were read and the officers worked, and they would have sent their information to the control station. There's one in New Zealand. I visited this one, and in front of that's been knocked off, but you can see would have been meters and so on inside there. Now that was actually taken in 1943. That building's still there, but the the front, and all the loops are equipment, galvanometers are not there. This is in Port Moresby, at a just in on a hill just at the entrance to Port Moresby. You can see it's sort of fairly low down, but there's enough to be able to see over the harbour and Fairfax Harbour, and people actually living in it for a long while. Here they are. This is people have set up home in one of the huts related to the loop station. That's a generator hut. Sydney Harbour, there's a big one. Look, I'll just quickly go through the Japanese midget submarine attack in May. They had, the Royal Australian Navy had put 6 loops, outer loops, around the harbour to Sydney. And they also had an inner and outer loop, much smaller, miniature loops if you like. But on the night of the 31st of May 1942, there were 5 or so Japanese submarines, big ones, well over 100 metres long. Now they would have been detected by loops easily, but they had midget submarines which are only maybe 25 metres long. Now a couple of these loops were out of action, and they didn't have enough watchkeepers anyway because of the manning problems in the war. So none of these loops were working on the night of 31st of May. We had these 2 inner loops were working. The outer loop was picking up a lot of terrestrials and industrials, so it wasn't giving very good signals, but loop 12 was. So as there were 3 midget submarines came in, they were all detected on the inner loop. 2 were sunk, and I show here these were sunk by depth charges. One was tangled, or no, only one's really by depth charges. The other one got tangled in the wire netting. There was a boom netting across here, and they decided to demolish the submarine itself. So they set off charges inside the submarine. The third one, oh, that's a picture of one of the submarines being recovered. You can see how the depth charges, well, I don't know if this is the one with the depth charges or whether the submariners inside there, the midget submarine, set off a charge to destroy it. The third submarine escaped, and it was located 14 kilometres north of there's the Sydney Harbour loops. It was located where I've got that pin, 2006. They took a long time to find it. They knew it was probably somewhere up the coast, but it was pretty hard to find. Just to show you why it was hard to detect the midgets, look, the outer loops, 190 metres between legs, and there's one of their big submarines. Now that would have been detected easily by the outer loops, the big loops, because it's big. But look how the midget submarine's only small. It wouldn't have given a strong signal on these outer loops anyway. So it wouldn't have mattered if they were working. The midgets probably would have passed unnoticed. But the inner loops, much closer together, and you can see the submarine, even the midgets would have been detected, because they're about a third of or quarter of the distance across between legs. So that would have been enough to detect them. After that, they put up what was called miniature loops, which were even closer together, and a midget was about half the distance between loops. Okay, so that's about it. That's a good introduction to indicator loops. Hope you enjoyed it. So that's it. Goodbye.